We would like to start panel 2. This panel focuses risk and concerns associated with influenza gain-of-function research. First, the panelists will identify and discuss the range of concerns that have been raised over influenza gain-of-function research, including biosafety risks, biosecurity risks, dual use and informational risks, and the implications for national and global security in conducting the research. We have 10 panelists, so each panelist will going to speak 5 minutes, and after that, we have moderated panel discussion among the 10 panelists. Then we are going to go to the open discussion for the audience. We have 3 important discussion points. First one is, what are the specific risks and concerns associated with influenza genome function research? And second point is, which components of influenza genome function research experiment raise particular concern? And the last one is, are there experiments that should not be done? And if so, why not? So we would like to start from the first speaker. First speaker is Ilaria Capua, Director of Research and Development Department, Istituto Zooprofilattico Sperimentale delle Veneziane, Italy. Dr. Capua, please.
Yeah, I have this honor and very good job to start off this discussion. Lucky girl. Okay, so I thought I would pick up on what Tom Inglesby said earlier, and in citing one of my points of view on this issue. And this comes again from me being active in the field and being active mostly with developing countries. So I think that there is a very diverse situation around the world with reference to potential of carrying out these experiments and potential of these PPPs, potentially pandemic pathogens, to be released. And I personally think that the issue of the concerns, which are mainly related to accidental release, are not a major concern in certain parts of the world, namely in this country. I think that in this country you have all the systems in place to avoid that accidental releases can occur, and also in many European countries. I don't think that a similar situation occurs in other parts of the world. And I also think that this problem needs to be addressed, not with reference to what is going to happen tomorrow morning or within the next year, but with reference of what can happen in the next 20 years or so. Also with technology which is becoming more and more widespread. Many people in this room have taught colleagues from developing countries to use reverse genetics. And reverse genetics, which maybe 10 or 15 years ago was something only used by a handful of laboratories, is now widespread and is used virtually everywhere. Now, I will refer particularly to Egypt because, as I say, we do a lot of work with Egypt, but Egypt is just an example. And I believe that if we project the outcome and the implementation and the outcome of these experiments in 20 years' time, technology will be greatly available, and there will be several laboratories, maybe hundreds of laboratories around the world which could hold these pathogens. Now, if we forget about bioterrorism, which is not my field of expertise, what I can tell you is that some countries have social unrest and have other problems which are related to, well, many factors, including civil issues, which can have an effect on the accidental release of these pathogens from the laboratory. And I would like to just mention what has happened in Egypt with the Arab Spring and with the revolution. The veterinary laboratory was looted. And these things happen, and so my question is, in a nutshell, if we generate this data and this data is being put in the public domain, and I am a supporter of the public domain, just so that, I mean, we get things right, and exponentially more and more labs will be able to use this information to do their own experiments, and these viruses will be kept in laboratories which are not, which do not have the biocontainment measures, but because they live in because they are placed in a country which is a country in which biocontainment is difficult. I think that the risk of accidental release may occur. And going back to Tony Fauci's question, which I think we really need to pinpoint and concentrate on, is, does NIH want to support the funding of experiments which can have repercussions on public health, such as the accidental release? I think that if we continue to disclose this information, this cannot be ruled out. Thank you.
Thank you very much. Let's go on to the next presentation. The second speaker is Don Woolley, Associate Professor of the Department of Neuroscience, Cell Biology and Physiology, Wunschelt School of Medicine, Wright State University, United States. Dr. Woolley, please.
Thank you very much. I was asked to speak on the biosafety risks and the OC health. The biosafety risks for gain-of-function research with highly pathogenic avian influenza are enormous, considering that loss of containment for a variant with increased virulence, increased transmissibility, or both, has the potential to be the most devastating pandemic ever seen to humankind. Currently, Biosafety Level 3 Enhanced is the recommended level of containment for high-path avian influenza H5N1, for the reconstructed 1918 strain, and for the H2N2 pandemic strain circulating between 1957 and 68. Risk Group 3 agents, such as these have been determined to be, are those associated with serious or lethal human disease for which preventative or therapeutic interventions may be available, representing a high individual risk but low community risk. The rationale for allowing work with these viruses to be conducted at BL3 Enhanced was based in part on pre-existing immunity within the population, either residual from previous pandemics or cross-protective from contemporary strains, sensitivity of the strains to current antiviral medications, and low transmissibility, in particular for the avian H5N1. Risk Group 4 agents are those that are likely to cause serious or lethal human disease for which preventative or therapeutic interventions are not usually available, thus representing a high individual risk and a high community risk. Variants created during gain-of-function experiments have the potential to display novel antigenic properties, thus no pre-existing immunity in the community at large, and they have the potential to be resistant to all current antiviral medications. Logically, then, such novel variants fall into the Risk Group 4 definition. In conducting this type of research, we must plan for the worst-case scenario, a novel antigenic variant that is drug-resistant. And even if such a novel variant were sensitive to current medications, there are serious limitations on the use of these medications, and the supply would very likely not keep up with the demand. We must also assume that we cannot quickly produce a protective vaccine against such a novel variant. We need only turn our attention to the recent 2009 H1N1 pandemic to see the consequences of this. By the time the vaccine for this strain became widely available in December 2009, the peak of this pandemic had already passed. Fortunately, the case fatality rate for this strain was relatively low. If gain-of-function research for highly pathogenic avian influenza is conducted, It should be conducted at biosafety level 4, which is the highest level of containment possible, including the most stringent engineering, procedural, biosecurity, and administrative controls. The occupational health requirements for such research must also be of the highest level, including things like baseline serum storage, exclusion of individuals with immune-compromising conditions and medical contraindications, a robust personnel reliability program, vaccination requirements for specific strains, if available, and for seasonal strains, implementation of pre- and post-exposure chemoprophylaxis, rigorous testing of all new variant strains, preferably phenotypic over genotypic testing, should be conducted to determine the sensitivity of the viruses to the existing antiviral medications. Detailed training on the signs and symptoms of influenza illness and strict reporting requirements for laboratory workers must also be in place. The vague nature of influenza symptoms makes this challenging. Workers exhibiting any signs or symptoms of infection should not be allowed to stay in self-isolation, but rather should be moved to a fully equipped isolation unit as soon as possible in the safest manner possible to avoid additional exposures while a medical assessment is being conducted. Close contacts must also be considered as well. In summary, my comments represent some of the highlights of the biosafety risks involved in conducting gain-of-function research on highly pathogenic avian influenza, and I look forward to a detailed panel discussion on these issues. Thank you.
Thank you very much. Let's go on to the next presentation. Next presentator is Arturo Casadeval, Professor and Chair of the Department of Microbiology and Immunology, Albert Einstein College of Medicine, Yeshiva University, and member of National Science Advisory Board for Biosecurity.
Thank you.
Dr. Casadeval, please.
Thank you. So I think it's important to keep in mind that gain-of-function is a research tool. In fact, it is a human tool for probing nature, and it is a very, very powerful tool. And there was we knew a lot about influenza before such experiments could be done, and you can probably learn a lot without doing gain-of-function studies. So I'm very reluctant to take such a powerful tool off the table on principle alone. Should gain-of-function experiments be done? I think so, yes, provided the two questions are answered. Is there information from gain-of-function experiments that is critical for pandemic preparedness that cannot be obtained by other means? If the answer is yes, this rationale has not been clearly articulated. In my opinion, basic curiosity that drives most science is not enough. If the work is supposed to inform surveillance, then surveillance needs to be done right. If the work is supposed to inform vaccine development, I would like to see the rationale how this will lead to be used in that case. And to my knowledge, this has not been clearly articulated. The second question is, are there alternatives to gain-of-function that provide comparable information? And here the answer must be no, for the gain-of-function experiments to be done. But before you say that the gain-of-function is critical for providing certain information, I point to you to cosmology. We are in the midst of a revolution in understanding the cosmos. It is all done from description and observation alone. And it is hard for me to believe that there aren't alternatives for getting this information when astronomers cannot knock out a galaxy or give a gain-of-function to a black hole and see what happens around it. And yet they can explain most of what has happened in the universe and where the universe is going. One solution to this controversy, which has already been mentioned, is to make safer viruses. For example, in Ebola, the Ebola example, a lot of work has been now done at BSL-2, including the identification of the receptor. In summary, I believe that gain-of-function should be done provided that a compelling rationale is developed and that there is no alternative ways to obtain this information. Now, as to the specific questions that I was asked to address, what are the risks? I think this has all been well laid out already: biosafety, biosecurity, containment, etc. However, I will point out to you that there is a huge risk in not doing the work and not doing the right work. The flu research community is society's best defense to the next pandemic. And this is a community, and I will tell you, I am not a virologist, I'm not in the flu community, I'm coming from the outside. This is a community that needs to be kept healthy. And regulations that stop the work, even if it's an additional form, will hinder the recruitment of very, very bright people into this area. So Dr. Fauci's slide showing the mortality of each pandemic, each one was lessened than the previous one. Why? Because of the advances that were made in the 20th century in medicine and in research. Hence, I emphasize the work needs to get done. Which components of gain of function raise particular concern? I think that all of those that fit within the NSABB definition of DIRC, increased transmissibility, increased pathogenicity, altering host range, and certainly introducing acquired resistance. So I've been asked to answer the question, are there experiments that should not be done? Well, the ones that I can think of should not be done are combinations of attributes. In other words, to make a virus, for example, not only mammalian transmissible, mammalian pathogenic, and drug resistance at the same time. I will not combine the attributes. I would do gain of function. I will tell you that I think that the community should be focusing on making safer tools. I think that it should be possible to separate transmissibility from pathogenicity. In fact, we already have that. We already have a virus that is pathogenic and not very transmissible. So it should be possible to have vectors that are transmissible but not pathogenic, and so great care should be taken before combining any of these attributes into a single virus. I have heard one of the problems that we're facing is that this community has to develop some of these tools because they've been able to do these experiments. Well, I think the landscape has been changed. I think these tools have to be developed, and I urge you to always remember that the most important protection against the next pandemic is this community that needs to be kept healthy, vibrant, and functional. Thank you.
Thank you very much. Next speaker is Gary Kobinger, Chief of the Special Pathogens, National Microbiology Laboratory, Public Health Agency, Canada. Dr. Kobinger, please.
Thank you. I'm just going to, I'm surprised I'm the first one to say that, but I'm just going to start with a little disclosure that my opinion and position does not reflect necessarily the position and opinion of the Public Health Agency of Canada nor the Government of Canada. So I've actually targeted more, or tried to answer the question that were asked, and wrote this down. I'm going to read it to you. As for the concern associated with H5N1 gain of function research, the first one was about biosafety risk. And I think the question is more, is the biosafety containment not adequate for the proposed work? Is there viruses that are known, existing virus or envisioned emerging virus that could not be safely handled in the highest containment currently available or lower? Would we need different conditions than what we have? With my experience after 10 years working as the chief of the Biosafety Level 4 lab in Canada, I don't know any of those viruses. Even if we take, as a matter of fact, one that was just mentioned previously, smallpox, it is officially restricted to 2 locations, but it's not because other labs could not handle the virus safely. In terms of biosecurity risk, international misuse of information, there's always risk with everything we do. The question is, are they acceptable? Can they be efficiently mitigated if things go south? And because I'm from Winnipeg, I like to go south, so I'll say if things go wrong. Are the benefits worth the risk? Basically, it's always back to this risk-benefit ratio. This always applies and is currently applying not only in biomedical research, but more broadly to other fields, including physics, including engineering, including medical management. About drug use research, informational security regarding the experimental details, etc., that are released, there's always those considerations, and they always must be part of the decision-making as much as biosafety and biosecurity. And what of the undermining of international public health agreement? Actually, this is a quite interesting point I've seen on this list of questions, and this point was already raised, at least in Canada, after the creation of recreation of 1918 collaboration with Yoshi, the 1918 influenza virus, because one angle was that it was breaking the Geneva Convention. Again, I think for all these points, the appropriate framework must be in place to evaluate gain-of-function research. Locally, a lot can be done. Nationally, a lot can be done, and also internationally in respect to current guidelines or agreements. Which component of H5N1 gain-of-function research raised particular concerns? And here there was transmissibility, pathogenicity, altering the host range combination, and I think they all raise concern to some extent. Again, it is a matter of debate and opinion and speculation as to which one is perceived more dangerously and more risky than others. But you're back to what are the benefits, in my view, attached to doing the work or not doing it. And this is often what is not put on the table very clearly. And I know everybody's alluding to it, but it's a point that's very hard to make. It is easy to see the risk of an accidental release, for example, of highly transmissible H5N1. But it's not easy to convince and to explain the risk associated with not doing the work. And they are there. Are there experiments, and I'm going to close this quickly, that should not be done? An experiment that are trying to reproduce a known or anticipated or plausible environment that can be encountered in nature should be considered. Until we can detect a new H5N1 and make protective, curative measures or clinical modalities available to the global population within days, let's say less than a month, to not be prepared could have consequences more serious than an accidental or intentional release of a known specific mutant that we know of, that we have been working with. If 1918 will head tomorrow as a novel emerging influenza virus without the knowledge that we have because we have recreated it, the global population could be as vulnerable as in 1918. In that respect, the pause on transmissible H5N1 has been and is preventing the evaluation of currently available vaccine and therapeutics against these new viruses, and therefore evidence-based decision, including biocontainment classification, is left to educated guessing, at least in part. Experiment that could be seen as unwarranted, again considering the risk-benefit ratio, are experiment not reproducing conditions found or plausibly found in nature where artificial conditions are created, for example, to force the system and force the generation of a new pathogen. Hybrid viruses could be part of this, where a variant component or a defense component of an infectious agent is introduced to create with an intent pathogenicity could be an example. But even here, the question remains, what is the benefit to public health and the ratio with risk? Thank you.
Thank you very much. Next speaker is William Colglazier, from Science and Technology Advisor to the U.S. Secretary of State. Dr. Colglazier, please.
Thank you. Well, Dr. Fouchier and Dr. Mahmoud both mentioned the Think report, which was this 2003 U.S. National Academy report, Biotechnology Research in the Age of Terrorism, produced by a committee chaired by Jerry Fink. In addition to laying out some of the categories of experiments of possible concern, it also had a number of recommendations, one of which helped lead to the creation of the NSABB. In the intervening decade, there have been many technical advances, and the pace of change of research is likely to increase perhaps even faster in the future. And as our capabilities have advanced, many scientists and security professionals have worked, I think, thoughtfully to try to develop the tools to minimize the very real risk of intentional misuse of biotechnology, including of the highly pathogenic avian influenza in particular. But these two communities obviously have a shared interest in a safe, secure, and responsibly conducted life science research enterprise. Actually, there have been many conversations about H5N1 among these communities, which actually reside inside the State Department. Many of my co-panelists have a much greater expertise in this area since I'm a physicist, so I thought I would contribute some thoughts on the risk in sort of a broader international context. The seventh recommendation of the Fink report called for a harmonization of international oversight. Today I believe that's even more important than when the report was released, that countries cooperate, both their governments as well as their biological research communities, to develop appropriate mechanisms tailored to meet each country's specific needs. And I certainly don't need to tell this group of the increasingly global nature of the research enterprise. Good research can emerge in many countries in both the public and the private sectors, and good research ideas that go unfunded by the U.S. government can be redirected elsewhere. So thoughtful oversight of U.S. government-funded research is obviously important, as this conference is focusing on, but it's also important to consider the risk that, absent synergistic international oversight, that research might still be performed elsewhere, but without due attention to the mechanisms being constructed to balance the risks and the benefits. And elsewhere does not just mean in the territory of some shadowy rogue regime or an extremist group. We must also think about the tools that we need to engage the global private sector, and in some cases even the growing community of do-it-yourself biologists that are operating in their backyards. Rita Colwell, in her introduction to a National Academy's brochure on understanding biosecurity for the global biological research community, emphasized the need to focus on promoting a culture of responsibility, enabling and empowering scientists to be vigilant stewards of their science, which I think is especially important. Also, Dr. Digraph did not mention it in his remarks this morning, but the Inter-Academy Council, of which he co-chairs, produced a report not long ago on responsible conduct in the global research enterprise, which actually talks some about H5N1. The fact that NIH is sponsoring this workshop demonstrates the importance that NIH places on international perspectives in shaping their framework for the gain-of-function HPAI research, and I applaud NIH for doing that and for using some of that input in making its future decisions on possible funding as we look to the future. International dialogue, coordination, and cooperation are essential to any effort to mitigate the risks of bioterrorism effective. At the 7th Biological Weapons Convention Review Conference, Secretary Clinton underscored the U.S. government's commitment to building an environment of openness and collaboration in our biodefense enterprise. And she outlined a series of unilateral, voluntary planned activities called the Biotransparency and Openness Initiative. In support of this initiative, one such activity is to promote scientist-to-scientist engagements through regional scientific hubs and seek collaboration between U.S. scientists and those from other parties to the convention. The dual-use nature of biological weapons agents, production equipment, and advances in biotechnology can make it hard to distinguish between offensive and defensive work, and means that we must find tools to increase openness while encouraging compliance among the state's parties. Because dual use has been a persistent issue, this transparency initiative seeks to promote opportunities for scientists to work together in cooperative and transparent ways to increase international understanding and to build capabilities in areas such as biosecurity infrastructure, global biosurveillance, and disease outbreak characterization. The goal of such efforts is to help reduce the risks and concerns associated with specific research programs, but without hindering the scientific advances that can be brought to bear on both improving human health as well as our understanding of the biological world. Thank you.
Thank you very much. And now I'd like to introduce our next speaker, Dr. Gerald Epstein, who is Deputy Assistant Secretary for Chemical, Biological, Nuclear, and Radiological Policy for the Office of Policy at the Department of Homeland Security.
Thank you very much. I'd also like to thank the organizers for the opportunity to speak with you today. I hope to bring the perspective not only as someone from the Department of Homeland Security, but also from someone who has been thinking about issues of the governance of dual-use biotechnology for a decade and has been working at the interface of science, technology, and security for almost 3. I'd like to leave you with 2 main points today. First, that extremely consequential research warrants a greater degree of scrutiny, as with the framework we're discussing today. And I'd also like to spend a little time talking about the breadth of misuse scenarios, which I think the term bioterrorism does not capture and indeed may be misleading. In terms of the consequential research, it's clear that the stakes are much higher with the research we're discussing today than with almost any other form of scientific research, where the great risk is wasting money or possibly not spending money on something which would have higher scientific return. Here, we are evaluating the risk of generating, whether accidentally or deliberately, a global pandemic, potentially putting millions of lives at risk, and weighing that against the risk that failure to do research would leave us less prepared for such a pandemic that might break out naturally. So the stakes are clearly high here. I think it's entirely appropriate that the decisions made on this category of experiment be made with utmost deliberation, with a wider range of parties and a wider range of criteria than typical decisions. The department unequivocally supports the type of cost-benefit analysis that this proposal calls for, and we, as Dr. Gerstein mentioned in the morning panel, we go through exercise like this in our own activities. I think the very existence of this policy, our discussion today, recognizes that there is a line beyond which we should not go, that there are scientifically meritorious proposals that for other reasons would be judged not to be worth their cost. If that were not the case, we'd all be wasting our time. If there were no possibility that an evaluation of the form we're discussing could lead to a decision to either forego research or do it under more restrictive conditions, then there would be no point in having this exercise at all. I think this is an important exercise to have. Let me turn a bit to misuse scenarios. I'll leave biosafety risks to others, and again, other panels have talked about the benefits. But in terms of misuse, I think we have to be extremely humble in assuming that we can know or understand the motives and the capabilities of those who might want to create harm on a massive scale. The concerns include those that go beyond, and in fact I think have little to do with, what might be called bioterrorism. If by terrorism we mean acts to inflict harm against non-combatants or civilians for a political objective. In this debate, we've often heard that pandemic flu would be not a useful terrorist weapon, that it would not serve terrorist objectives to wreak that kind of indiscriminate harm. Whether or not that is the case, we have to consider the possibility of misuse by individuals or groups whose goals we would not predict and whose motivations we may not even be able to comprehend. We don't have to look very far in the past to find acts of violence inflicted by people whose motivations seem beyond comprehension. And it's that greater possibility, not so much the idea that a terrorist group may seek to use these capabilities, that one has to keep in mind. We cannot exclude the possibility of psychopathology, individuals with a very warped set of objectives and desired means for pursuing them. I think a point that others have made, Dr. Inglesby and on this panel, Dr. Capua, have pointed out that we also have to be very leery of limiting our consideration of potential misuse to those who have the capability to do so now. Once information is put in the public record, it's there forever. And as has been pointed out well by my predecessor on this panel, technology continually evolves, barriers continually lower, interest and capability in biotechnology penetrate new geographic areas and permeate the economy in ways that will continually make any given level of capability easier to attain over time. Now, can I be specific about the people, the places, and the probabilities of misuse that I'm so concerned about? No, I can't. But it would be dangerous to believe me if I said I could. We may be worried about the actions of people who have not yet formed an intent to act in a certain way, or about groups that have not yet been formed. But we do have to recognize that when this type of research is done and creates the possibility of misapplication, that possibility will persist. So we have to be very careful not to inappropriately define a narrow sense of the biosecurity or misuse concerns, and we have to be very careful not to overly constrain the time frame in which we're trying to consider our views. Thank you very much.
Thank you. The next speaker is Dr. Seth Karras, who is Deputy Director, Center for Counterproliferation Research and Distinguished Research Professor at the National Defense University. Seth?
Thank you. In the next couple of minutes, I'm going to try to provide a national security perspective, speaking not as a scientist, which I am not, but as somebody with a background in national security affairs who's had a long interest in oversight of potentially sensitive biological research. In that regard, I don't pretend to represent all the alternative views in the national security community and have to put in the obligatory disclaimer that I don't necessarily reflect the views of my own department, the Department of Defense. There are two key framing perspectives that are important to keep in mind in this regard. First, there is reason to worry about the misuse of biology by bad people. Some countries do retain offensive biological weapons programs. There are still some terrorist groups interested in acquiring such capabilities, and occasionally we find individuals who consider using biology to inflict harm. It should be noted, however, that interest in biological weapons is relatively uncommon, and actual use of them is even rarer. Moreover, at this point, most bioterrorist activity is crude, not likely to benefit from advanced biological research. Historically, it's perhaps worth pointing out that the total number of people who've been killed by all known uses of biological weapons is a fraction of the number of people who die every year in the United States from pandemic or from just seasonal influenza. Having said that, the past may not be a good indicator of the future, and I would associate myself with the comments that Dr. Epstein made about the uncertainties of predicting who might misuse this kind of science. Now, a second framing perspective is that because of these concerns, the international community in general, and the United States in particular, developed a web of treaties, other international agreements, laws, regulations, and policies intended to prevent such misuse of biology. Now, while I'm not a lawyer, it is my understanding that the intent of these efforts is in no way designed to limit research. The focus of those efforts is on preventing the acquisition and use of biological weapons. It's not intended to limit research in developing defenses against biological weapons, and certainly not to limit research in the public health arena. So what does this mean for the issue we're discussing today? The fact of the matter is that if the H5N1 research that we're discussing today that NIH sponsored had been sponsored by the department that I work for, the Department of Defense, for exactly the same scientific purposes, it's likely the United States would have been falsely accused of violating its treaty obligations, and the State Department would be busy defending ourselves against charges of U.S. continuing to maintain an illegal offensive biological weapons program. Now, we deal with these kinds of concerns, both legitimate and often not so legitimate, in the national security realm by instituting oversight mechanisms which are known to the international community and to domestic constituencies. Department of Homeland Security in particular has a pretty rigorous process, which I think managed to alleviate a lot of concerns that were expressed some years ago about its activities. Now, I find that most of my colleagues in the national security community understand the importance of disease and infectious diseases and recognize that the benefits of such research, even though there are people intent on misusing science. In some cases, this recognition is very specific to our communities. Thus, many of my colleagues in the Defense Department worry about the health of our armed forces, which depends on exactly the same public health medical countermeasures developed for the general population. And those involved in biodefense are interested in enhancing our understanding of scientific processes. Let me conclude by addressing one specific issue. I find it difficult, perhaps impossible, to identify ahead of time specific research that should not be conducted. Such decisions, it seems to me, are context dependent, depending on the nature of the science and the related public health, medical, and policy questions that the results would address, and as such can only be determined through a thoughtful cost-benefit analysis. Hence, as a non-scientist, I would not arbitrarily rule out any particular research projects, but would rather rely on a risk review process intended to ensure that dangers and benefits are understood and evaluated by people with the authority and responsibility and expertise to do so. Thank you.
Thank you very much. And now we'll move on to a presentation by Dr. Priti Sasono, who is a senior scientist at the National Institute of Health Research and Development at the Ministry of Health in Indonesia.
Thank you. The Chairman, distinguished participants, ladies and gentlemen, first of all, I would like to thank the NIH for inviting us and giving us the opportunity to come and share our experiences on avian flu research. We understand that the objective of this workshop is to solicit perspective on HPAI H5N1 gain-of-function research, and specifically in this session, we are discussing about what are the specific risks and concerns associated with this research, and which component of these experiments raise particular concern in terms of transmissibility, pathogenicity, and alteration of host cell of the viruses. Ladies and gentlemen, talking about risks and concerns associated with research, especially involving highly pathogenic infectious diseases agents, we know that there is a biorisk management knowledge to deal with it. Biorisk management, which consists of biosafety and biosecurity effort, is how to manage microorganisms, especially infectious diseases agents in laboratories, and it has become an important issue in the world during the last decade. Biosafety issue has occurred in history due to the increase of incidence of laboratory-acquired infections. Afterwards, biosecurity issue rise when dual usage of disease agents, either for good or other risky intentions, started. In the last few decades, the world has seen the emerging of several new infectious diseases. Most of them are potential epidemic forms, such as SARS and avian influenza. Many factors may induce the occurrence of these diseases, both man-made as well as natural factors. The phenomenon of cross-species jumping of infectious diseases agents from animals to humans are also frequently seen. Efforts such as disease surveillance, early detection, and prompt responses are critical to prevent, control, and eradicate these diseases. Moreover, vaccines and antiviral drugs are also created as the results of the research in the laboratory. For this purpose, capability laboratories with sufficient safety and security levels are highly needed. In many developing countries, zoonotic diseases are still belong to the important health problems. Zoonotic diseases are diseases which are caused by infectious agents and can be contracted by humans and animals. Therefore, biorisk management implementation is important, not only for laboratories in health sector, but also for the veterinary sector. There are many challenges faced by developing countries, including Indonesia, in developing biorisk management. The challenges faced by Indonesia are the archipelagic nature of the country, the disaster-prone location of the country, the climate, the huge number of its population, the diverse culture and tradition of its people, and its biodiversity, including the microorganisms which can cause various kinds of communicable diseases. A laboratory safety program is important to protect the lives of the laboratory and health facility employees and patients, to protect laboratory equipment and facilities, and to protect the environment. The laboratory is a complex system involving many steps of activity and many people. The complexity of the system requires many processes and procedures to be performed properly. Test results produced by laboratories that are widely used in clinical and public health settings and the outcomes of health interventions are dependent on the accuracy of this testing and reporting. Therefore, ensuring safety and quality research during laboratory processes is major concern. Ladies and gentlemen, in conclusion, research in the laboratory which work with dangerous pathogens, no matter what it is, will increase transmissibility or pathogenicity or even alter host range of HPAI H5N1 virus. Therefore, their safety and security risks need to be managed in responsible manner. Program or management system to address these biorisks should be developed and implemented. The ultimate goal of a biosafety management system is to ensure an organization's biosafety management objective to be achieved. This system must be based on a strong legal framework. Before I close my remarks, it should be borne in mind that an essential factor in reducing risk of the spread of infectious diseases is a prevention step, which includes raising the awareness of the community on how diseases are spread. Therefore, research in public health issues involving community-based studies should also be the flow. Let me close my remark by expressing my sincere hope that this workshop will come up with brilliant ideas to be instrumental in the enhancement of the cooperation among government officials, experts, and researchers all over the world in preventing and combating avian flu pandemic. Thank you.
Thank you. Our next speaker is Dr. John Parker, who serves as the chairman of the National Defense Science Board and is senior vice president of the Science Applications International Council.
Thank you, Dr. Cox. I've experienced a lot, including having a major role in the biological threat reduction program across the globe. I'm not a virologist. I'm not an authority. However, I am an advocate of programming scientific investigation to achieve a goal. It is important to be able to answer the question, what is the goal and why? My position is that I agree that no classified biological research should be done. I believe that controls are necessary, but the controls that we put in place should be reasonable, sharply focused, and they must be executable. I agree that the work needs to be done. I ask you, is this an issue for the scientific community in isolation? Or should we be speaking to our communities and nations in the vocabulary pertaining to doing this work? If the public doesn't see the value and want this done, should the work be done? Why did we put salmonella into a microgravity environment? Was the outcome part of the hypothesis? Why do we do genetic knockouts for cancer research? Is there an analogy to that model? The questions posed as written in question 2 all raise concern within multiple communities. However, it's important to understand that we, as human beings, tend to form our initial opinions on the basis of intuition and emotion. This, of course, is directly related to our experience and knowledge. We then, when given the opportunity, allow reasoning to become a greater component of that thought. The initial intuition and emotional response may become tempered. Taking these questions and rephrasing them puts a different light on the subject. Suppose we were to ask, what causes transmittability? What causes pathogenicity to increase or decrease? How does the virus change its host range? The context of the question could be everything as we talk to the community and our civilian communities. Now, we see the original questions differently, and our ability to move away from emotion and intuition is attenuated. We now can engage in reason because we have reframed our thought processes and patterns. In doing so, we have moderated our potentially exhilarated deliberation. So we end up saying yes to the question. All 3 questions, singularly and combined, raise concern. They should. However, they now become risks that must be mitigated if we are to move forward to increase our knowledge, increase our ability to detect, increase our ability to protect, and increase our ability to intervene. Intent is everything. I am sure we are going to discuss this along with controlling policies. Age and experience become harsh mentors of our ability to successfully change a potential bad or unpredicted outcome. Viruses, like other living organisms, strive for balance. Many researchers have told me, as they tell you, Manipulation in one area has consequences to the organism. Increase its transmittability may decrease its virulence. You know all the permutations, I need not go on. All science has a risk of being used inappropriately. Do we suppress and cloister science, or do we find better ways to detect those who may have psychological, moral, or ethical aberrations that are at variance with all of humanity? Thank you very much.
Thank you. And now our final speaker for this panel is Dr. Harvey Rubin, Director at the University of Pennsylvania Institute for Strategic Threat Analysis and Response, and Professor in the Division of Infectious Disease at the School of Medicine, University of Pennsylvania.
Thank you. I've been asked to speak specifically about questions 1 and 3, so I'll take 3 first. Are there experiments that should not be done in the context of HPAI H5N1, in particular in gain of function? So let me say my default position on this is the same as Thomas Jefferson. When he founded the University of Virginia, he said, this institution will be based on the illimitable freedom of the human mind. Here we are not afraid to follow the truth wherever it may lead, nor are we afraid to tolerate any error so long as reason is left to combat it. So that's my default position. There are no experiments that shouldn't be done. However, in this context, reason is the key thing, and we've heard a number of reasonable explanations and reasonable objections to doing some experiments. In terms of gain of function, I think as the life sciences converge with biology, but with physics, mathematics, and engineering, gain of function is absolutely essential. The cyber-physical program at the National Science Foundation actually is premised upon that fact, that if we can actually engineer something in and predict its properties, that is gain of function. If the life science research and this particular field is to go forward with all the reason behind it, we have to do gain of function experiments. We have to put them in the context of mathematics, physics, and engineering, or else we will make no progress. So that's my brief answer to number 3. My not so brief answer to number 1 is undermining international agreements. Do anything we're talking about today actually undermine international agreements? Well, the problem with this premise is, what are the international agreements? And I would say that the most fundamental international agreement was already written in 1948 in the United Nations, saying that health is a fundamental human right. So I would put this in the greater context of the international human rights of health, and how do we devolve it from that point? There's a very contentious point in climate law now, which is called common but differentiated responsibility. So are the developed worlds more responsible for the climate disaster that we are facing? The international considerations in infectious disease is actually quite different. And there I would call it common but differentiated capabilities. And you've heard a lot about that this morning. Let me be more specific. In a project that we're doing with the Hague Institute for Global Justice, we've been asked to survey the landscape of international agreements and how does it affect infectious diseases. Well, the capabilities are quite different, but the rules and regulations and the advisory committees are legion. So we have the World Trade Organization, we have the Biological Weapon Convention, we have NSABB as an advisory board, export controls, Australia Group, international health regulations, the trade-related aspects of intellectual property, TRIPS, and now we have the United States International Strategy for Cybersecurity, which clearly deals with how we're going to exchange information over the web. All of these international agreements directly affect the kinds of things we're talking about here today, and clearly affect individual scientists. You don't have to go very far into the audience to realize and recognize individuals whose research have actually been stopped according to certain of these kinds of rules, regulations, and agreements. So I think what we have to do, and this is something our group at Penn is trying to do, is figure out what are the legal landscapes? How does the science impact the existing legal landscapes? And how does the changing legal landscapes and advisory landscapes, like the document we'll be considering later today, how does that impact the forward movement of science? That's just not well known at this point. And in fact, what I'm concerned about is that we will put in place regulations and rules and advisory committees that will hinder the kinds of research that absolutely have to be done, as Arturo clearly said. So I think that What we really have to do is recognize that science is an international endeavor. There was a National Science Foundation study published just last August showing that in the life sciences, 23.9% of those responding actually have international collaborators. So one set of rules and regulations that are in effect in the United States will clearly impact a colleague overseas. And we can't have our heads stuck in the ground and say, what we do here in the United States has no impact overseas. It clearly will. So we have to figure out a way to come together, and we heard that this morning already, to have this harmonized approach without suppressing science. And I think to get back to this notion of common but differentiated capabilities, we have to be concerned that there are places in the world that can't meet the set of criteria that we will set up. So this differentiated capabilities has to be something we have to take very, very seriously. Thank you.
Thank you very much. I want to thank all the panel members for staying to their time very carefully. I think there must have been some practice done prior to this session. In reflecting on some of the thoughts that we've heard today, I can see that there are some people who approach this from a very philosophical point of view, while others approached it from a much more definitive point of view with very specific conclusions about what needed to be put in place and so on. And I don't quite know how to blend discussion when we had such different approaches to the set of questions that this panel was to address. So I think that I'd like to reflect. I think it would be most useful for this panel to really reflect on question number 3, if we could, just a bit more, because I think this is kind of at the heart of what it is that we're talking about. And question number 3 is, are there experiments that should not be done? And if so, why not? And I guess I would like to just open it to panel members and ask them to speak to this question, because I think this will help NIH and folks overseas the most if we kind of focus on this particular question. So do I have, yes?
Thank you, Dr. Cox. I'm one of the ones that speak philosophically. I believe that if you cannot speak to why you want to do a specific piece of research, if you have not really looked at the why, the intent, and the possible consequences, if you haven't met those criteria of knowing why you need to do the work, it shouldn't be done. So I guess I sum it up by saying that intent is everything, and if you have positive intent and can't explain the why, that particular individual or that particular organization should not be doing that work.
Thank you. Other comments?
So as a former member of NSABB, I'm not on the committee anymore, so I can speak more freely, I guess. Don't forget, dual use of concern doesn't mean don't do the experiment. And we were very clear, at least in the early days, and I'm sure it's the case now. It doesn't mean don't do the experiment. It means be reasonable, understand what it is you're doing, understand how to communicate it, understand how to educate the students and the public. And when the decision to publish the Spanish flu papers came out, everybody, Kurzweil and Joy in the New York Times wrote an op-ed piece, said this is the end of the world. So nothing bad has happened since then, as far as I can tell, from the Spanish flu set of experiments. And it was all predicted this, all hell would break loose. So I think the key thing here is reason. And I don't know how many of you have written NIH grants, but if you don't write the significance, and if you don't write very clearly why you want to do these experiments and what would happen if they go wrong and so on, and are the facilities up to date, and are the human subjects protected, are the animal subjects protected, there's a whole bunch of stuff you have to do when you write these grants. So that goes without saying. It's the kind of folks that Jerry has reminded us that I think are the real problems. And we can't predict who's going to be out there and should we tailor our set of experiments for the worst of all psychopaths in the community. I'm not sure I'm willing to go there just yet.
Thank you very much. Yes.
One advantage of working in a department with 200,000 other people is that we rarely require me to make a decision on something like this. It would be certainly a collective act. But in terms of what shouldn't be done, I would look at the actual phrasing of the NIH proposal that we're evaluating today. I don't think that's on the screen now, but for example, one type of experiment I think would be hard to defend would be creating strains that would be extremely unlikely to arise if it were not for the fact that we were creating it. And in that case, we would be accepting the risks of such a work, but we would not be attaining any benefit because we would be anticipating a problem that was extremely unlikely to happen. I realize a lot is tied up in extremely unlikely, and that's what the discussion would key around. I think a second category, looking at another of the bullets in the proposed review framework, would be experiments producing results that for whatever reason cannot be usefully applied in mitigating the concern that is motivating that work. So again, all I'm doing is restating objectives that are in the review framework, saying these are the questions one should ask, and if one can't answer them, then that's a clue that maybe the work that's being proposed doesn't meet that bar. Setting an objective criteria, coming up in advance with specific quantities, types, approaches, protocols, will be very difficult, but I think those are among the questions that one needs to be able to answer.
Thank you. Arturo.
I think that whatever gets done, there ought to be sunset provisions. For example, whatever we decide, it should be at this time, because things move very rapidly. You know, I drew the line in making a virus that is highly pathogenic, transmissible, and drug resistant. I mean, I think at this time, that probably is very hard to defend. On the other hand, I could imagine that things could move. And that I could imagine that you would need to know that information because it turns out that the three attributes together influence yet another aspect. So one of the things that worries me, and I go back to this, is that all these regulations, and as you begin to put in all these red flags, people, the smart people, the people basically which are limited, are not going to be doing this work. Why would you want to be a graduate student or a postdoc doing a lot of this work if in fact society makes it so difficult? On the other hand, we need to not only protect society but also make sure that this community remains vibrant. And one of the problems in microbiology is that, and you can see this across fields, when fields don't have tools or where fields cannot do certain experiments, they tend to fall behind.
Thank you. I think Harvey has another comment.
Entirely, I think that's right. If you start limiting the human ability to question and push the boundaries, that's going to kill the field. And in particular, the issue that we were discussing, that Jerry raised about unlikely to arise, there's a whole area now of biological research looking at stochastic events. And it turns out, and I think you've even, it turns out that the unlikely events may in fact be very, very important. In fact, they are very important. So this notion of being able to predict ahead of time that this may or may not be important because it's unlikely probably won't fit in with the current way we think about important evolutionary concepts. So stochastic events, unlikely events, may in turn out to be very, very important. And whether that's a combination of other unlikely events or just a single unlikely event, we don't know just yet. But we have to be able to look at it. And I think in the context, we could think of very safe ways to ask those questions, and those are the kinds of things we do on the benchtop. And we can think of very unsafe ways to ask those questions. We have to be able to make the case that asking those kinds of questions in the context of H5N1 is a serious question, and that's where the discussion should go.
Yes, Dawn.
Yes, well, I'm a basic researcher, but I'm also a biosafety professional. So I fully understand the benefits of basic research. And I think that if we do gain-of-function research, there's no doubt we're going to learn a lot. But what I was hearing from the first panel is that what we learn may not directly translate to saving us if this were to be released accidentally or however. And so, and that's often the case with basic research. It's not directly translational. Sometimes it can be. And I'm also not convinced that the natural transmissions that have occurred, that goes back to the question that I asked in that session, I don't think we fully exploited the information that we could have gotten from those natural transmissions and done all of the molecular analysis and biochemistry and everything else that could be done. And if we haven't done all of the work on the natural ones, why create new ones that we then have to study as well? And so I strongly support studying some of the natural isolates, and I think that there perhaps are experiments that we should not do, and I think we really need to seriously review the ones in creating mutations that might not occur naturally. And it's really hard to make blanket statements. I've served on a number of IBCs, and it's hard to make these blanket statements without a specific protocol in front of me with all of the details.
Thank you very much. Are there any other comments? Yes.
Well, actually, I have a question, if I can ask the panelists. In the two papers that were published, there was a long debate beforehand about whether some of the results should, the methodologies and some of the techniques should not be published, and I know the decision ultimately was that all of the work would be published in the open literature for the research that the NIH might conduct in the future based on the framework they've set out about what things that are worth funding. Do the experts here think it's possible that some of the unclassified basic research may come up with information that you will conclude after the fact not all of it should be published in the open literature? Before we heard the only way to deal with that kind of thing is by classification at the moment. There was discussion before about was there another category, the category that could be employed where legitimate scientists with the need to know may gain access to all of the information that was excluded from a public report. But I would be interested, is there in the research that might be funded in the future, do you think it's possible that there may be things that are uncovered that you will conclude after the research is done that not all of it should be published in the open literature?
So Gary, would you care to address that?
I think it's a difficult question, and from what I've seen, there's a self discipline to do things the right way from the scientific community. I know there is sometimes experiments that go one way, and scientists themselves feel maybe uncomfortable the way it's going, so they will not go that way, and instead. So now, how do you regulate that and all this? But I think there's a lot to do with engagement, and as I was saying, there's a lot that can be done locally and nationally and internationally. But it's for others to decide, in my view, if there is information that comes out of specific studies, if there should be a way to communicate that information to only a smaller group on a need-to-know basis.
Arturo.
So one issue that has come up repeatedly, including by the questions that I laid out, is the usefulness of the information in combatant preparedness. And I think it is important to realize that even if one cannot at this moment identify an immediate usefulness, that humans are very creative, and that information may become useful in the future. I give you general relativity. You could argue that there are a lot of physicists in the room, and they know this better than I do, but the slowing of time as a function of gravity, was really not useful until we had cell phones. If it's only then that I have to introduce the correction in GPS for my cell phone to work. So I would keep these two things separate in some ways. I think we needed to make the rationale for the very difficult experiments, but information itself can become useful in the future.
Thank you. Yes, John.
I have a lot of trouble with cloistering information, especially scientific information. Anytime you try to put what you're doing under any sort of a silk cover or an iron shield, you create a perception that something is happening that shouldn't be happening. And so the perception becomes very, very powerful. And the only way to break that perception down that you're not doing something wrongful is full disclosure. Now, help me here, because I might say this wrong, but one of the groups that was very successful in sort of containing their research work was the nuclear physicists around the Manhattan Project and years after they formed the Janus Group, I think it was called. And it appeared, we looked at it on a couple National Research Council committees that Jerry Epstein and I were on, and it was very functional, but it may have outlived its time, and I don't know if you can do that anymore by saying, we will distribute the information, but it'll be a precise community. So I don't think people should try to suppress information. What we have to do as we evolve as the human species, learn how to deal with that information appropriately, and in the process of that, learn how to detect and identify those personalities that may not have the capability of dealing with it that way.
Thank you. Others? Yeah, Harvey.
Complication is that if you have students, and part of the reason the NIH doesn't do classified, Penn, we've debated this a lot at the Faculty Senate, we will not take classified grants. If you have a student working on a project and all of a sudden somebody steps in and says, this is not only maybe sensitive but not classified, but certainly classified, there goes the student's thesis and work. So it's really hard to step in after the fact. But the ancients dealt with this too, and so Odysseus would tie himself to the mast and dealt with partial knowledge, right, and didn't go to the island of the Sirens. So there's ways to deal with it, but you have to deal with it up front, and you can't impose these kinds of rules and regulations, at least at the university center. How this work plays out in national labs and the pharmaceutical industry, that I don't know. But at the university center, we just can't do that.
Thanks. Yes, Dawn.
I think we need to think about the timing of the experiments, and maybe the question is, are we ready for these experiments now? In my scenario, I put forth some arguments, thinking of the worst case scenario. We talked about the combination of attributes, whether that's intentional or it comes about during this experimentation. Increased virulence, increased transmissibility, and not amenable to a vaccine. If those things came together, and they could, whether it's intentional or unintentional, and it accidentally gets out, I'm not even saying intentionally gets out, it gets out. We can't handle it. We are not ready to handle it. And so should we be doing something right now that we are not ready to handle? That's a question I'm putting out.
Thank you. Gary?
I just want to add a few comments. But Mother Nature may do it for you, and then you're not prepared. So I don't know. I was a little bit surprised with the first panel that the clear benefits of those studies were not understood, especially in terms of surveillance, because it had right away a clear impact on the capacity to detect those mutations and associate them with phenotype. But what I want to say is that I fully agree with the problem of I think that if there is no, if one is not able to disclose fully, it means that the benefits globally are not justifiable enough to make it happen. And I think this is why, and there is example of this where science goes one way and then stumble onto a finding, and out of a sudden this door is not worth anymore going through, because the question is it still of benefits globally? Is it going to be important and useful to communicate? And if the answer is no, then I don't think it's worth pursuing at all.
Thank you. I think Ilaria had a comment next.
Yeah, I just wanted to touch on a few things that I've heard from the panelists. I heard from Dr. Rubin that, of course, it is obvious that we have some institutions around the world who are capable of managing this sort of work. and others that can't. And we have to make clear that there is this distinction. The problem is that you can identify them, but you can't really prohibit anyone to do anything. I mean, how are you going to stop them? And this goes back to other things that we've heard this morning, which is that you can't stop technology. I mean, you can find anything on the web, and so my concern is that if you put in place a regulation and you say these are labs which can and these are labs which can't, the ones who can't, if they want to do it, they just say, well, so what? You know, if I want to do it, I'll do it. And also identifying personalities, which has been mentioned, I think that this is extremely difficult. And forgive me if I take a fully Italian example, but this man who drove a 4,000 people cruise ship into a rock, which had been there forever. I mean, I expect that this guy had been, and this was not an Italian company, it was a multinational company, so for once, you know. No, but I mean, you know, these things happen, and this guy ran this big cruise ship into a rock and put at stake the life of 4,000 people. And I'm sure that he had been, you know, proven to be fit for purpose. He obviously wasn't. And one last point I'd like to make is that I'm a little bit confused with when Arturo said, you know, I wouldn't do work on double mutations. What I fail to understand is, would you not do it at all? Would you do it as classified research? Or what? Because I think that there's the key question which was posed by Tony Fauci at the start is, should NIH fund this work? And therefore NIH only funds work which can be disclosed. So I think that we all recognize the importance of work. There's a gray area which maybe the benefits of releasing all the information may be not as, maybe not an efficient cost-benefit analysis. So what I'm asking you is, do you refer to classifying the research, or do you refer to not doing it at all?
Well, based on the other things that we have heard here, for example, the concerns about biocontainment, the concerns about biosafety, the fact that we are learning how to handle this, I think that unless you can come up with a clear scientific rationale for doing the work that is just not curiosity, then I don't see that the work should be done at this time, classified or unclassified or whatever. But I want to emphasize one thing, that I think it is really important that whatever gets done here has sunset provisions that will force the community to rediscuss it again. You know, if you're going to basically end up with a moratorium, 1 year or 2 years, and then rediscuss it again, because things are changing very rapidly. And I may give you a different answer a year from now. I think a year from ago, I would have given you a different answer. At the time, I was not as aware of the issues that we're discussing, and I would have probably said, you know, you should not, science should be unfettered. We should be driven by curiosity. And we should learn, because we don't quite know how this information is going to become useful. So my own view has shifted, and I think it may shift again. And I emphasize, my one thought to you is to make sure that whatever gets done has sunset provisions, so that it forces people to have this discussion again.
Thank you. Don, I think you had a
Getting
comment.
back to the idea that Mother Nature may combine these attributes on her own, yes, that could happen. So we need to do it first? Maybe not. I think Mother Nature has a way of surprising us, and what I'd like to see is some emphasis on something like a new vaccine platform that could be so rapidly deployed, it doesn't matter what comes up where, we can deal with it quickly. I mean, the money for research is very limited these days, and so we have to think also about where we're spending our money. Instead of trying to create something that may or may not happen, why not be ready for anything? And I know that's a big challenge, because that's already been worked on to some extent, but we may need to think about directing more funding towards that to be ready for any variant.
Thank you, Don. Yes, Dr. Sassano.
So I agree what Don Woolley mentioned also. The experiment that should not be done, for me, is not those case of the questions. Since we understand that H5N1 is mostly in Asia so far, and also in animals. And then we don't know that in natural what happened with the mutations. I think I'm agree that the experiments that should be done now is how we can prepare or prevent for the disease, is rather than create a new one virus. So it is much better to understand how the mutation happened from the last happened in H5N1 or H1N1, something like that. And then we can then make sure that how we can produce or make vaccine or candidate for the diagnostic and something else. So it's rather than we create a new one and then we don't know it will happen in Asia, or maybe because so far we understand that the research has to be in the appropriate laboratory, and then in developing countries there is no, maybe about the climate also can also affect the mutation itself. So we don't know so far if we make a new one creation to understand how the transmissibility or pathogenicity or something, and make maybe will make worse about altering host range and everything. Thanks.
Thank you. Seth.
I wanted to come back to this question of classified research. You know, it may be something that you decide you have to do, but people have to realize there's a real cost to doing that, in the sense that anytime you take work into a classified setting, everything takes longer, the costs go up, and in this particular case, you may run into the problem that there is no lab actually set up to do this kind of research, so you would have to create a lab de novo to replicate what exists outside of the classified setting. So, you know, the framework mentions the possibility there might be classified research, but it would have to be fairly extraordinary given just the complexity of making that happen. So I don't think that should be seen as some kind of default position, unless we're going to invest a lot of money creating a new infrastructure for doing influenza research in a classified setting, which doesn't seem warranted with what we've heard today.
Thank you. So for the very last few minutes of the moderated panel discussion, I'd like to ask panel members what they thought about Dr. Parker's suggestion to reframe questions 2A, B, C, and D with a different framework where you're asking the question, what causes H5N1 viruses to become transmissible? I thought that was an interesting comment. I thought it was very insightful, and I would like to hear from the panel members.
A lot from studying the natural isolates, and as I mentioned earlier, I don't think that's been fully exploited. So that question could be answered without creating these new gain-of-function variants.
Thanks, Don. John?
Well, one of the things that over the years that has been played with quietly, and then it gets loud, and then it quiets down, and then it gets loud again, is can we continue to go forward with one drug, one disease, one vaccine, one disease? And how do we evolve to a broader spectrum approach to infection so that we can develop drugs and vaccines that have more than one focal point? Now, we've been very specific about H5N1 as an example, but through the GOF type of research, I think it's important that there's a possibility that we may learn the genetic aspects of transmission that transcend viruses and bacteria, et cetera, which could be a very big discovery, and we could discover the genetic focus of of pathogenicity or virulence, and this would have a dramatic effect on the future of medicine and global health. So I'm an optimist, but I'm a surgeon. I have to remind you that I wear a big type A on my sweater, but I wonder if we're getting too tied up with the fears of the statistics of H5N1 virus, 59% mortality. That's scary. But I want people to think in a broader way as to how these discoveries can be used in a broader way.
Thank you. So we've had two comments. Are there other comments from our panelists on the question of whether reframing the questions is useful for the discussion going forward? Yes.
I mean, I feel that if we can reframe the questions in a way to better communicate with the public, I think that is something very worthwhile. I think that scientists generally speak to one another in very complicated languages, and I think anything that we can do, ultimately the public is supporting the science because the public is interested in protecting itself against it. And I think we need to explain to the public why this experiment should be done. And I thought Dr. Parker's reframing the question is a very good way to start a dialogue.
I'm sorry,
Yes.
but
One last comment.
there are so many things on the plate today, all competing for $1. Those people who win out and get dollars are the people who are able to get the American public energized. If the American public is not energized, foundations aren't energized, the Hill's Foundation is not energized, and what you find is that your source of income to do this wonderful work is forever decreasing because people don't understand value. And I'm very afraid that if we don't engage the public, we're going to end up on a very tight, narrow trough of funding for our work.
Okay, thank you very much. I think we'll finish the panel discussion and we'll move to our co-chairs and ask Dr. Feinberg. Oh, you have some comments? Yes, Robert.
If I can start, I found very interesting that actually in this panel also the issue of the risk of not pursuing certain research was presented. And actually the case was made that there's a big responsibility also just on behalf of the scientific community. And just a question to all of them, I mean, what would your advice be in terms of kind of strengthening internally within the scientific community, the researchers, the scientific integrity and responsibility?
Thank you. Additional comments?
I have another different question that I'd be very interested in the panelists' comments. It is, where do you feel the burden of proof should rest? Do you begin with a default expectation that new scientific knowledge is good in the near term and the long term, sometimes in ways we cannot even anticipate, and the burden should be on those who demonstrate that the risks outweigh that potential scientific benefit? Or do you begin with the default that this is a very dangerous organism, we should not do anything to make it more dangerous unless we can demonstrate the proof and expectation that the benefits of this research will outweigh that intrinsic risk? How do you begin and where do you put the burden of proof?
Thank you both for those very insightful comments. Now I'd like to turn over the moderation to my co-moderator.
Yes, now the discussion is open to the audience. Any questions or comments?
Okay,
Yes,
do you want to do that?
I'm sorry. I would like to mention about question 1 and question 2 because direct transmission from ferret to ferret does not mean the immediate risk of the human-to-human transmission, in my understanding. And the important point is safety risk and biosecurity risk is a different point, because accidental release is not a specific risk of the influenza research, and we would like to focus more on the how to mitigate the risks in such a case in doing influenza research. Yeah. And we would also like to focus on the importance of the education for life scientists. Currently, we are developing the educational materials for life scientists, and that can be applied more worldwide. And if scientists recognize the true concerns, then we would like to go in a new way to develop the more creative scientific research.
Thank you. And perhaps the panelists may wish to comment on the burden of proof, where the burden of proof should lie. So, Dr. Parker.
The burden, well, first of all, to answer the ultimate responsibility for the research to progress the researcher needs dollars. So where those funds are coming from, those funders of research bear a huge responsibility when they select among a series of protocols which one they would like to fund. That is so serious that organizations that are in the position to do funding for research must develop and must have at hand the right people to review these proposals. It's not one of these things, it sounds good to me, give them the money. We are way beyond that. And it brings up a whole other point that we may be on an educational cliff where we are running out of those types of people to make those judgments because we are reaching beyond. So there's a responsibility there, and Dr. Fauci and the NIAID is a living example of that responsibility. That's why we're here today. He wants to go away today having some sort of, he and his staff and his science policy people want some sort of satisfaction that they're on the right road making these decisions. The other thing is the scientific community, I don't know in a training program how much we talk about ethics and moral and scientific endeavor and all that sort of. If we give somebody an advanced degree in science, part of that should be that we're pretty satisfied with the fact that they can make a reasonable decision to write a particular protocol to go to a funder. That's a wild statement, but it's a shared responsibility, and through education, training, internships, postdoctorals, we need to just inculcate that so that it's a natural event.
Yes, please.
Just two quick comments on the burden of proof, which is an interesting question. Where you set the burden of proof, there are always uncertainties in these issues, and it makes it for the other side has the difficulty of dealing with the uncertainties. A question of not only how safe is safe enough, but how sure is sure enough. So I've always found it very useful to think on both sides of the question because of the uncertainties associated with the issues. And then Robert's question on the issue of scientific integrity. My own personal opinion is, from listening to all of the experts here, that there are public health benefits of conducting gain-of-function research of various types, and so it's good that NIH is trying to think very carefully about the framework making those decisions and funding, but because of all the other research that might be done in other venues, the private sector in other countries, it really, to me, some of the remarks that I made, it's very important for the biological community itself, the community outside of government, to really think very carefully about its own ethics and its own responsibility in terms of self-policing and self-governance. It's going to be as important, I think, as what the governments decide to do on their own.
Dr. Feinberg, I hope I can evade your question in a useful way. I first want to point out that for decades, the U.S. government has taken the position that basic research is such a fundamental, important good for economic potential, for fundamental human values, for national security, that it's certainly in the country's interest to proceed, even though there are foreseeable risks. The question is that, as a general rule, that's the case. Here we're talking about a very specific category of experiments, and I think the answer to the burden of proof, which is a very important way of looking at it, will depend on the community that you're discussing it with, which my takeaway is that's why it's important to have multidisciplinary reviews. And building on Dr. Kogelator's recognition of uncertainty, as this is an oversimplification, but the scientific community, I think, may clearly see the benefits that the research can provide, and they may see some of the risks are clearly foreseeable as well. Some other risks may be a bit diffuse and vague and hard to operationalize. It may be that some in the security community have the reverse approach, that they can see risks even though they're not quite crystallized, they're clear, whereas the scientific or public health benefit of some activity may be a bit more distant. So I think people will be coming at this issue from different positions on precisely that point, and I think that's why the deliberation on these topics needs to have a sufficiently rich set of participants that this issue can be explored from both of those directions.
Can I add
Just quickly, please.
I have to admit, I did not find the last question very helpful in the sense that, people who are intent on doing bad things with biology are drawing on the same science that all of the people in this room are drawing on. There isn't a separate set of science that's biological warfare. And so it seems to me there's always a risk that we willingly accept that somebody will try to misuse science that was done for perfectly good reasons that creates lots of benefits in other ways. I think that's why having a framework where you're trying to weigh costs and benefits is the right way to approach it, because there's always a danger that somebody will find a way to misuse it, and I don't think you can predict that.
Thank you. Now let's go into the floor discussion, please.
Hi, hello. Hello, this is Adolfo García Sastre. I'm an influenza researcher. I have a specific comment actually about what can we do to improve the biosafety risks that are associated with this type of research. And up until now, we have been concentrated in general in biocontainment, that is physical biocontainment. But if you think about gain-of-function experiments, these are specifically being done normally in an animal model. So there is also the possibility to insert attenuation mutations to a specific virus that you are working with, like H5N1, that will attenuate the virus for humans, but not affecting the behavior in ferrets. And I think we should also thinking about these potential molecular biocontainment techniques that can be added to the physical biocontainment in order to address better these biosafety risks. And I mention that because that's something that I've been working with Daniel Perez, that is also here, about how to achieve this, at least for these influenza viruses. Okay.
Yes.
Adolfo, I think that's precisely the type of thinking that is needed out there that gets us out of this. Can we get the information by other means? And I commend you on that. I think that is from the very beginning. To me, that was the way out, to try to create very safe vectors, to try to molecular containment, as you pointed out. So keep working on it.
Please.
Hi, India Hook Barnard, National Academy of Sciences. I'm kind of thinking about this in terms of quadrants for biosafety risk or public health. We've talked about the risks if the research is done versus if it's not. And Jerry expanded on the idea of the biosecurity concerns if the research is done, but I don't think we've expanded that in terms of fourth quadrant, which is what are the biosecurity risks if it's not done. And I'm thinking, just as you said, the technological developments are happening really rapidly, barriers are falling, people are getting information and they can do these things, whoever these people or whatever their motivations are, as long as you're considering those possibilities, there's also the possibility that they might be able to do that without this research being done, and that right now maybe we have an advantage that the researchers have the advantage, but we'd maybe be losing that if we're not doing the research. And so I'm just wondering if you're considering sort of that fourth quadrant in your scenarios.
Anyone? Yes,
I think, that's an excellent point there. It is incumbent on the national security community to not be surprised. There are clear risks involved in failure to understand potential inquiries that adversaries could take, and I think Dr. Gerstein can go into further detail on the approach that the department takes in trying to understand these. But yes, there are clearly security concerns from being surprised by people coming up with techniques we haven't explored. I do think that the total R&D resources available to people with public health and the humanity in mind vastly exceed the R&D resources available to those with different points of view. So in terms of pushing the envelope, I think it may not be a symmetric problem, but I appreciate your having pointed out that there are some concerns from failure to pursue even on security grounds, as a generic statement, not restricted to this particular area.
Yes, please.
Hello, George Christopher from DoD Transformational Medical Technologies. A question for the panel. To what extent can basic scientific questions regarding the determinants of transmissibility be investigated by doing gain-of-function research on low pathogenicity H5 or other avian low virulence viruses with limited or no transmission to mammalian hosts?
You're the only flu virologist here.
But I'm moderating.
If I can add, it's all a matter of, you can model from very simple system to more complex system, but ultimately what scientists tend to do is to try to model with the closest reality that is possible to achieve to be able to conclude more adequately on the data and the result. But every model has its value and its inconveniences, I think. And if I can just add on the because I thought that was two very interesting questions to me, how do you increase awareness in the scientific community? I think it's happening now. And this is a very good venue right now. And in the past year, it's not only the influenza field that has been learning a lot and communicating a lot and thinking a lot about all these issues, is also the eye containment field. And I would say all the infectious disease field, as a matter of fact. So I think it's a very important process right now, and this was very helpful at the different level. And for the other question, I thought it was a tough one, and I like the answer. But what I wanted to add is ultimately, again, something that I mentioned earlier, I don't know myself of any virus existing or even I can think of that would not have an appropriate level of containment to work with. So I think this is a big part of a possible solution in addressing questions that are thought to be important in terms of public health, is that there's a way to work with any kind of possible viruses, in my view. Thank you.
Yeah, I just wanted to add that, to bring us back to where we started from, the problem is H5N1. I mean, we're all doing these experiments because we are afraid that a virus which is endemic in many countries may spark off a pandemic. So it doesn't really make sense to start working on a virus which is, a one-off in a wild bird isolate, and that doesn't have those very peculiar characteristics that H5N1 has, because we don't have to forget that H5N1 is a truly unique set of viruses, because no other influenza virus of high or of low pathogenicity has contained all the peculiarities, particularly relating to animal health and to human health, that H5N1 has. So I really wouldn't see a point. I mean, it would take us I don't know, like 20 years to get the model right, and we may all be dead by then.
Okay, please.
Kanta Subarao from NIID, NIH. I just have a comment, and it is about questions come up about whether we've articulated clearly how vaccine research could have been modified based on the findings that have been published. So I'm going to essentially reiterate what Nancy said at the end of the first panel discussion. And I can see it happening in two ways. Again, it's theoretical because we haven't been working with these viruses. But mutations in influenza viruses that affect receptor specificity, transmissibility, and other properties could also alter antigenicity. And we would need to know whether the changes that have been identified that enhance transmissibility would actually affect antigenicity. If the answer was yes, then we would need a different vaccine candidate. If the answer was no, what we have in the stockpile or previously prepared vaccine candidates would be adequate. On the other hand, what's been described has been described, as others have said, in the Vietnam 2004 and Indonesia 2005 strains. There are many other clades out there. So that the additional experimentational question for vaccine purposes would be whether similar changes would affect antigenicity and or transmissibility of other clades of H5 viruses.
Thank you. Please.
Thank you. I'm Marianne Donker. I'm from the Ministry of Health in the Netherlands. Well, first I would like to make a comment on the discussion that we have been having the past year and also today. And then I have a question to the panel. My comment is that it seems that on the field of the benefits of this kind of research and in the field of the risks of this kind of research, we still are very much insecure about how much the benefits might be or how severe the risks might be and where these risks might be. So we finally end in kind of discussions on principles and things like that. But I think that the question of what are the potential benefits of this kind of research is in part an empirical question. I would like to commission a study, for instance, to really map out what can we do in surveillance, what can we do in vaccine production with this kind of results of research. But now I want to focus my question on the panel on the possible risks, because also the possible risks, we have touched on them in the past hour, on possible risks of laboratory safety in countries where there's a lot of unrest and where even laboratories get looted by the population. Things like that, we have touched on the risks, but I really would like to have a much clearer understanding of where those risks are in laboratory safety all over the world, not just in the Western world, but all over the world, on the possibility of misuse of rogue states, of the risks of failed states getting this kind of technology within their borders, things like that. And I think it would be very useful when working with the framework that the United States is developing at the moment, if we have a more empirical, common understanding of those risks, so that not in every case, every research study that applies for funding, we have to find out these risks and improvise at the moment about the cost, the risk and benefit balance. So I would propose that we might work a little bit on getting more empirical common understanding of the benefits and definitely also of the risks.
Any comments?
I do agree that we really need to more clearly delineate the benefits. Just based on what I've heard and read, I'm not completely convinced that the benefits outweigh the risks. I think that basic science information is generally useful in the long term, but we have to get to the long term. We have to live to get there. And in the short term, the worst case scenario we have to plan for, we are not ready to deal with it at the current time. If the worst thing happens, we're not prepared.
Yes, please.
I'd like to just say also that, which highlights a very important part, is that as awareness is growing exponentially, I think in the scientific community, one part that could use a lot of improvement is communication between the scientific community the regulators, and the people, the public. I think this is where there's a lot of room for improvement, so that the public is better informed on the benefits and can judge better on those possible benefits. Just a minute to put a little bit things in perspective, because we're talking about H5N1, highly pathogenic, transmissible between ferrets. In my opinion, there's more dangerous viruses out there, and they are contained and they are worked with every day. And a lot of the speculation that is happening right now is not happening for those other viruses. Not to say they will never happen, but what I'm saying is let's keep this a little bit rational. Again, that it's maybe again a matter of debate, but there is a lot of more aggressive and more dangerous viruses out there than this one.
Okay, the question, please.
Hi, I'm Edward Hammond. I'm a policy advisor to Third World Network, which is an NGO with offices in Malaysia, Ghana, Uruguay, and Geneva, and former U.S. lab biosafety, gadfly. I wasn't going to say anything, but I can't let that question 1D go by without a specific consideration vis-a-vis the PIP framework at WHO. Because if we had a meeting like this a few years ago, the question that would have been on the table would not have been, are we going to do gain-of-function experiments on virus isolates? It would have been, are we going to acquire the virus isolates at all? Because the problem at that point was that a number of developing countries, not just one, were not providing virus isolates to the international community because, or to the WHO system in particular, because it was felt that there was a lack of sharing of information and practical benefits from research that was conducted on them in the North or in the developed countries. And if in proceeding with this framework, we begin to undertake a large amount of research that a large number of people feel should be restricted somehow, either by classification or by some other bizarre artifice to try to keep it within a certain closed group of people. What I think a very real risk there is that you're going to create another situation that parallels the one that led to the crisis that we had several years ago, where there was a breakdown in international cooperation because it was not felt that there was adequate information flow and an equity in the relationship between developed countries and developing countries that had endemic virus problems. So I think that it merits very serious consideration looking into the future on this issue in particular, thinking about what will the effect be on the countries where this virus is endemic in terms of their willingness to play ball with this group of researchers writ large, if they feel that they're being dealt out of the results that come from this research. And, you don't want to have government lurch from almost fixing that last problem. And we may, within a matter of months, have new money from the private sector going into the PIP framework to support surveillance. Isn't that what we want? But we don't want to undermine the PIP framework then by creating this world of information that will not be seen as being accessible by countries whose cooperation is needed, not only by us, but the whole world needs that cooperation.
Any comments? Yeah, please.
That's a really good point, and that's why this notion of common but differentiated capabilities as a fundamental framework for a global governance structure is really important, because that it leads to a way to incentivize countries to participate with a recognition of differentiated capabilities, and in some sense be able to support those capabilities or maybe put a governance structure in that says you can't work on this for various reasons, but have it in an incentivized governance structure that's agreed upon by all parties.
Okay, we have 2 questions, please.
Yes, Peter Hale, Foundation for Vaccine Research. This session obviously is about risks, and it's very difficult to assess the risks if people don't have all of the facts. For example, we have had extreme difficulty accessing statistics that would tell us how many accidents or incidents there have been in labs in the last 5 years where a lab worker has become infected. So my question, I think this is for Dr. Woolley and maybe Dr. Kapua, is what reporting mechanisms are there in place that would answer that question and identify what kind of incidents, whether they were major incidents or minor incidents? And why isn't that, if I'm assuming there's a reporting mechanism in place in this country, but why isn't the data more readily accessible?
On lab-acquired infections, the ones that we know about are just, the tip of the iceberg. Some of the lab-acquired infections are just not detected. They happen and it didn't cause a lethal disease and, literally not detectable. Sometimes some of the lab-acquired infections just mimic other common infections and they're not pursued. There's a lot of psychological reasons why people may not want to report something. We could probably use a psychologist on the panel to delve into that. I mean, there's the denial factor. There are people who have even recently died of lab-acquired infections who were experts on that agent and failed to recognize the symptoms and act quickly, and they could have been saved if they had. We're working right now on the new biological safety textbook, the American Society of Microbiology, and we do have someone trying to accumulate data. But a lot of it is anecdotal. There's no real formal reporting mechanism, especially at universities. If you get a needle stick, sure, you're supposed to report that, but there are a lot of accidents and things that happen that just simply go unreported and undetected.
It be to put a reporting mechanism in place and make it mandatory, at least for BSL-4 labs if you're working with tier 1 agents?
Yeah, even in my 5-minute summary, I said absolutely, if this work is done, it has to be the most rigorous surveillance possible. But with this particular virus, again, the symptoms being very vague, I think it's going to be a challenge, for the workers. But I think the training has to be of the utmost in terms of, you would think that if they're working on the virus, they're experts on it, they should know the symptoms. But again, this is a very vague list of symptoms. We all know the list is huge for influenza, and it mimics so many other things. And so then you've got the challenge of, people just coming down with a normal cold and overreacting, and how many things get reported and how many people go in isolation. But in terms of the biosafety level 4, it is the highest level that we have, and I think the reporting is the most rigorous in that level of containment, and that's why I would suggest if it's done, that's what we would use. An accident, certainly in an environment like that, would have a much higher likelihood of being reported to the appropriate authorities.
So we're eager to get to the bottom of, to answer the question, what is the incidence of accidents in laboratories? How often does it happen? We've heard numbers like in the last 20-year period from 1978 to 1999 that there were 1,200 incidents in BSL-4 labs in which a lab worker was infected. We've not been able to get any data since that, and we still don't know who did that study. It's awfully important to know. If we use those particular numbers, it suggests that there are between 50 and 60 incidents a year in BSL-4 labs where a lab worker is infected. Could Dr. Kapua answer that, because there's an international component to that as well?
I can talk at least for the one I know, which is the one in Winnipeg, and 100% of the incidents are reported. They are public, And actually, recently we had, it cost $5 to get all the records of all the incidents that were reported since the opening of the lab. And we have a structure where we have to disclose to the public the incident within 48 hours. And the delay is because we may have other things to do first in terms of attending the person that was subjected to the accident. But again, 100% were reported, and all this is public.
Excuse me, could I make a comment that addresses that point? I work for the Select Agents and Toxins Program for CDC, and we in fact do have a regulatory requirement for reporting exposures to select agents immediately. There is a mechanism in place. We collect the data and the information. And in fact, the paper's been accepted for publication and will be out within a month. So we have 5-year history. And we collect information on every BSL-4, and there are no fatalities in any of the BSL-4 laboratories. So I thought I might add that. Thank you.
Is that from a known accident? I mean, because there are cases where someone has just been in a laboratory, there was no known accident, and they acquired an infection. Now, I'm not talking about just biosafety level 4, I'm talking about, in general, biosafety labs.
Well, we work with select agent labs, and we have a definition for reporting that includes a known occupational exposure as well as a release from primary containment inside these laboratories. So all these are reported, required to be reported within 24 hours and followed up by a written documentation. And we submit a report of that to Congress every year.
I think it's become very clear that there's a lot more reporting and housekeeping that's done that really isn't known about. I think Tony had a question.
Nancy, I just want to throw up for consideration, I know we don't have much time left on this panel, but maybe on any of the panels, of a little subtlety vis-a-vis the decision-making of whether or not we would fund, apropos of the question I put up on my slides. On the next to last slide, in the second bullet, I put up the point that makes things much more complicated, and that is that in the discussions of the NSABB, when you talk about funding, obviously there are biosafety right up there, biosecurity, things that you take into considerations. And when we fund a group, as I emphasized in my presentation, like Ron's and like Yoshi's and others who are well-trained, well-regulated, experienced, et cetera, et cetera. True, there is the possibility, as we mentioned, that there may be an accident, but that's a group that's very, very highly capable of conducting the research. The situation that was brought up in one of the discussions is that you're not worried that much about them, and it isn't who we fund that people are concerned about, but it's the people who will then use the research from the people we funded. So the real fundamental question is, when we make a funding decision, do we have to make a decision based on funding even the most careless, most unregulated, because they're going to use the information? That sets an extraordinarily high bar for what you're going to fund or what you're not going to fund, because you're going to say if people are going to use this information, they may use it with no biosafety or biosecurity concerns. So I'd like to hear sometime during the next couple of days where that consideration fits in our funding decision. I mean, it's very, I wouldn't say easy, but it's clear when you're funding people who have a very good track record, who are very well trained. But do we need to take into consideration beyond that? Not who we are funding, but who's going to use the research information that we're funding. That makes a decision very complicated.
Thanks, Tony. That's the last word before Harvey's.
Thank you so much. I apologize to those who wanted to speak now, but I will look forward to hearing from you when we reconvene this afternoon. We've got some very important discussions coming up. We'll have a chance to return to Tony's question. We're going to be looking specifically at the framework. We're going to have a number of case studies that will help enliven and inform the discussion. But for now, first, please join me in thanking this marvelous panel for their excellent discussion in this last hour. Thank you all very much.